All right. So my name's John. Today I'm going to be presenting on the work we've done to validate some of the ideas behind SQL on FHIR through a peer-reviewed scientific paper. And I'm also going to introduce the open source SQL on FHIR implementation that I work on called Pathling. So I would describe myself as a research engineer. I kind of work at the intersection of standards like FHIR and SNOMED CT and data analytics, trying to create tools to make it easier to actually adopt these things. I'm also the lead contributor on a number of different open source projects, including Pathling. And I've been along on the journey, the SQL and FHIR journey, and made some contributions there as well. So why write a paper anyway? Like, what actual practical use does this provide? Oops. So I don't actually have a sort of academic background until more recently, and I've actually found a lot of value in this process. And I think that's something that's maybe others could get value from as well. What it allows you to do, or forces you to do, depending on which way you look at it, is it makes you describe concepts in a rigorous way that other people can build on, designed to be able to be built on. It forces you to validate and that the concepts work for their intended purpose, and indeed prove that they can be used for their intended purpose. It forces you to kind of systematically scan for other solutions to the problem that already exist, and then look at all of those solutions, compare them to what you're proposing, contrast them with what you're proposing. And it kind of forces you to convince a bunch of impartial, uninterested strangers that your idea has merit. Because, of course, you convinced yourself about it long ago, and you kind of biased yourself into loving your own idea just by spending so much time on it. And the people within your orbit kind of have experienced the same sort of effect, but it's a different proposition, trying to get other people over the line. And some of these other people might have, their own sort of, opinions and solutions and biases. So it's just a really good way of actually doing a sense check on what you've come up with, which is really important in standard space, I think, because whatever we create in standard space gets multiplied over and over, and we all have to live with it for a very long time. So Arjun kind of did a nice articulation of the problem that we're trying to solve earlier. Maybe I can sort of have a crack as well, maybe from a slightly different perspective. So FHIR was originally designed for exchange, not analysis. We can sort of concede that. It's difficult to use with analytic tools in its raw form. Yes, you can sort of say it's just JSON, but you have to understand all the semantics that come along with that, whether it be all the FHIR data types, all the different types of resource references, how to do extensions, etc., etc. If we push the burden of knowing all that stuff and doing it all correctly every time onto every single person who wants to do health data analysis, that we're going to really raise the bar of this, of what we're asking of these people. And we're also going to maybe pay for it in consistency of the outputs. And, you know, the problem is that we've had a lot of different goes at sort of solving this problem. And we're going to talk about some of them in a moment. But arguably, none of them have really managed to be both simple enough to implement widely over a really broad range of technologies, lots of different implementations, but also be expressive enough to be useful. And with SQL on FHIR, we've really put a lot of thought into exactly what the right trade-off is between simplicity and expressivity. And it is different to any of the other solutions. So from this kind of, so if we can kind of articulate that as a problem, we can then kind of come up with a research question that we can then investigate. So can a view definition specification with deliberate constraints on scope and expressivity achieve practical implementation across diverse technology stacks while supporting real-world analytic use cases? And we have used this question to drive out a whole paper that investigates this question. And in doing so, really put our own solution kind of under the microscope in terms of whether it is the right and the best solution and the best trade-off. So onto the prior art. You may or may not be aware that there was a SQL on FHIR before SQL on FHIR, and it was more of a way of querying FHIR data in place, nested FHIR data within a relational database using the features of SQL that allow you to unnest nested data. And this is fine. This is a totally valid approach. In fact, it was implemented in some areas. However, where it falls down is the portability of SQL dialects in terms of querying nested data. We can achieve really good SQL portability with tabular data, but once we get into the constructs that we need to unnest nested data, there is actually, unfortunately, a lot of variability in implementations. So that was actually one of the drivers of the SQL on FHIR v2 spec, is what could we do and what sort of different architecture could we try to address this problem? So that's a little bit of lineage there. And we've got lots of other solutions that play in this space or in a similar space, including SQL, which is a much bigger specification and really tries to address a different problem. And we've got some which really helped inspire what we did, like FHIR query language. Pathling has had a similar flattening sort of operation for a long time. And more recently, SQL has actually created similar constructs within the SQL standard itself. It's still a long way from achieving broad sort of adoption, but we can also look to that for inspiration as well. And also things like FHIR mapping language, which is a more general sort of language that can be used for what we're doing, but because it's more general, it's also arguably more difficult to use. So we came up with a problem statement, a research question, we did an environment scan of all the different things that are out there. Okay, now how do we actually sort of demonstrate that what we've come up with is actually fit for purpose? So we can describe the way that the SQL and FHIR ViewDefinition worked, and Nikolai did a really good job of that just now. But how can we actually show that it can be used for non-trivial use case and actually achieve the attributes that we're saying? So portability, sufficient expressivity to actually be able to do, for example, a non-trivial research study. So this is where Mimic 4 on FHIR comes in, which is a parallel sort of effort that's been happening over the last few years, which came in really useful to do this. So Mimic 4 is a data set that was created from the Beth Israel Deaconess Teaching Hospital in the United States. They basically de-identified 10 years of their entire EHR data and released it. And then some enterprising people took that and converted it into FHIR format. So what that gave us was a really pretty rich, pretty big FHIR data set that we can actually run. We can use to test out SQL and FHIR, but we could also run real research studies over the top of that. And there are actually hundreds of papers that, you know, have discovered all sorts of things from the Mimic data. And what we did was that we picked one of these papers, which is an interesting study on racial disparities in oxygen supplementation in the hospital. So we picked this study and said, well, can we actually replicate this study from FHIR data by building a set of SQL and FHIR views over the top of it, and then a layer of standard ANSI SQL over the top of that? And then can we run the combination of those views and the SQL over multiple different independently implemented SQL and FHIR view runners? So the way we designed it, so on the left there, the original paper, they took the non-FHIR version of Mimic. They did a bespoke analysis process, and they came up with a set of findings. And what we did was we took that same data set, but in FHIR format. We designed a set of SQL and FHIR views over the top of it, and we designed some queries over the top of that, and we had an R-based analysis that did the final analysis over those tables. And then we took two different SQL and FHIR implementations. One is Pathling, which is implemented in Apache Spark, and one which is in AidBox, which uses a Postgres database in the back end. And we ran the same set of views over the same data using these two different implementations. Then we ran the exact same SQL queries over those results. And then we ran the R analysis over the same results. And we were able to not only get the same results between Pathling and AidBox, but also replicate the findings of the original study. So this is kind of a bit of a summary of what those views looked like in this study, but suffice to say it takes it a little bit further than just the example views that we would have come up with as part of the standards development process. It forced us to actually create something that solved a non-trivial problem and And the value of that was that we were able to demonstrate that we could use this to solve a real world research question. So the result was that we were able to get this published in a high impact journal, and we're pretty happy with that. So that's pretty much all I'm going to talk about with respect to the paper. Yeah, feel free to go and have a look. And also all the code that was used to replicate that study across both Pathling and AidBox is all open source on GitHub, so you can check that out. And the links are in the slides. And yes, so those people who are asking, we'll provide all the slides and this will be all posted up. Next thing I'm just going to briefly talk about is a little bit more about Pathling, which I've mentioned along the way. Pathling is a toolkit for doing data analytics for FHIR over Apache Spark. If you don't know what Apache Spark is, it's basically a big data processing framework. And on top of that, we provide tools that make it easier to get FHIR data in and also to run SQL on FHIR views, for example. So you can take data, FHIR data from a variety of different sources, including the FHIR bulk data API, so the bulk data export API. You can take just NDJSON files on a file system or cloud storage, FHIR bundles, and you can also ingest FHIR data as a stream. So for example, if you have FHIR events coming through using either something like message bus like Kafka or FHIR subscriptions, you can stream data in and to a query and transform it and put it out to another stream. So when we bring data in, we have a way of representing that FHIR data in a lossless way as a Spark data frame. And at that point, you can optionally persist that to your data lake using storage format that supports nested data like Parquet. But then we also have implemented a SQL on FHIR view runner, and the view runner in Pathling takes a view definition and it transforms it into a Spark SQL query. So it allows you to run that query over large amounts of FHIR data very efficiently and come out with a tabular data frame. So yeah, and to illustrate that, the full Mimic4 data set is about 580 million FHIR resources. So that gives us a little bit of we can start to test some larger FHIR data sets. The other nice thing about Apache Spark is that we can actually scale it beyond a single instance for processing. So we can actually run larger jobs over a cluster. And in fact, we did this using the CSIRO high performance computing cluster for the Mimic4 data, which was a fun exercise. Just as an aside, one of the other challenges with the Mimic4 data initially was just validating it. So the people who produced the Mimic4 data set didn't have the tools or compute power to actually validate it using the validation tools that are available in the FHIR ecosystem at the time. So we actually had to create a new solution which used the tools that we're familiar with, which is Apache Spark, to actually take the Java-based implementation of FHIR validation in FHIR Core and parallelize it using Apache Spark. So what we effectively did was to take our lossless FHIR representation as a Spark data frame and do like and sort of fan out and run the FHIR validator on each of those rows in parallel and produce like a report, a validation report on what any of the problems were with each of those FHIR resources. And we actually used that to fix Mimic 4 on FHIR and publish a new version. And we also open sourced that as another tool. So there's now a sort of Apache Spark FHIR validation tool that exists now because we did that work. Okay, so as I was saying, one of the things that makes Pathling somewhat special is that we can use it to construct streaming architectures in FHIR analytics. So we can have operational FHIR servers doing their thing, you know, people running transactional workloads over those FHIR servers. And, you know, it's problematic if you want to run analytics often on the same data store that you're running your operational workload on. Generally, you want a different space for your analytics that's set up with the performance characteristics that you need for analytics, which are quite different than your operational workload. So you want to have some way of synchronizing that data across to your analytic data store. But often you also want things to be up to date, right up to date, you know, real time, in quotes, as we call it. So what Pathling and Apache Spark allows you to do is actually run SQL queries and also SQL on FHIR ViewDefinitions over streams of data. So I did a bit of a demonstration of this where we sort of converted a real emergency department data set into a set of FHIR events, and we created a simulator for firing them off at a realistic frequency, and we pushed them onto a Kafka topic and streamed them off there and run them through a set of SQL on FHIR views and used that to create a real-time dashboard for the emergency department, for example. So that's the type of thing that you can use Pathling to do. And we've got more material on exactly how to do that, including videos, if you're interested in that. The other kind of unique aspect of Pathling is the way that it deals with terminology. So it actually has functions that integrate with a FHIR terminology service API at query time. So you can actually put these functions into your view definitions and have them resolved by a terminology server as the query is executed. And this includes caching in between Pathling and the terminology server. So for example, you can, if you've got SNOMED codes in your data, you could say which of these is a type of, is this code in this column a type of rheumatoid arthritis? And at query time, it could be making calls to the terminology service API, executing expression, a SNOMED expression to say, is this a subtype of rheumatoid arthritis, yes or no? And that coming back into a column in your view. The same goes for like, you know, translating between different code systems, which is a common use case. You know, like I've got a SNOMED code and I want to translate it to an ICD-10 code because that's what I need for sort of comparability with other studies or something. Or maybe I just want to use it for something like language translation. So if your terminology is multilingual, you can actually use the terminology server to actually walk between different language descriptions for those codes. So that's a useful and powerful capability as well. So what are we currently working on with Pathling? So we have shipped the SQL on FHIR View Runner, and we're currently working on reinventing our server. So we did previously have a server implementation for Pathling that kind of uses the same engine and exposes a sort of select few operations that are oriented towards analytics. What we're doing is we're currently building a new version of that, which is oriented around the bulk data ecosystem and the SQL and FHIR APIs. So the new server will support FHIR bulk export, which is already a widely implemented thing. It also has a bulk client to get data in from bulk export. We're also currently implementing the brand new bulk submit proposal. In fact, we're trying to participate in the upcoming Connectathon about that, which is a way of getting data into a server. And we're also working on the SQL and FHIR APIs that Nikolai talked about before, which are the run and export APIs. So we are hoping to release that as sort of a package of functionality. The other thing that Arjun mentioned was Parquet on FHIR. So we're working on sort of validating the concepts in that draft specification and adopting that as the underlying lossless representation that Pathling uses. And finally, we're also doing some work in the area of user interfaces, particularly in patient cohort query and extraction, so that we could leverage the SQL on FHIR API to kind of allow researchers to interrogate and extract data from multiple different diverse sources in a consistent way. So that's a little bit of a summary of the things we're currently working on. So that's all the content I have today. Thank you very much for listening. And there's some links if you want to, if you're interested in getting some more information.